Thank you. For some reason, it keeps muting my microphone, and I don't know why. So first off, welcome in everybody again. As I was saying, fortunately, I was rambling about a slight tech issue. That tech issue has now been resolved once. Interesting. So what I've noticed is that when my mic stops working, that tech issue happens. So if that issue happens again, I am very aware my mic is no longer working. I'm going to have to remember that. Hopefully you can hear me now, because according to OBS, it is picking up my voice. So what we're going to be doing today is two things. First, you still can't hear me? Really? Okay. What the shit? Oh, okay, now you can. Okay. Sorry, my still will come in after that. So we'll be doing two things today. First, we'll be installing Vulkan onto our game engine. We'll be setting up Vulkan to see if we can get it to work. We're going to do a quick demo to demonstrate that the Vulkan SDK is properly installed in my library. After that, once we got Vulkan working, what we're going to do is we're going to switch over to actually creating an instance or batch renderer. So currently, our renderer is a one-to-one renderer. So one 2D object, one sprite, one text, one UI element, what have you. Now, that is not optimal. So we will be trying to create a batch renderer, and that will be the second thing we do. So the first bit, again, is we're going to put in the Vulkan stuff. Sorry, I was going to say DirectX, and I'm going to do that down the road. I do still plan on putting on DirectX, but I want to try Vulkan just because, hey, I've not seen Vulkan done on YouTube yet. I have seen OpenGL in general. Now, for anyone curious about this, now, for those of you who don't know, that is, everything we've done to this point with OpenGL, with Glue and GLFW, we still actually need for Vulkan. In particular, we need GLFW, because otherwise we'd be relying on Windows 32 applications, and that ain't gonna fly, yo. So what we're gonna do is we're gonna use GLFW to create our windows still, to handle our input events. So with the Vulkan renderer, we do not need to have any special sort of stuff for input. Well, we do. We don't have to have anything new for input or window creation. We're just going to use GLFW for that. Now, when it comes to DirectX, however, we probably will have to have a different input class for DirectX. And that's the other reason why I'm avoiding DirectX right now is I'm not confident enough in GLFW yet to make it polymorphic to work, to make our input class polymorphic to work with both GLFW and DirectX. But again, Vulkan requires something else really for it. So, hey, I decided we're going to start with Vulkan. Now, I realize if you've looked at the Trello for this particular project, the Vulkan is on the block. Now, there are a couple of reasons I am moving it from block to active. First, I have found clearer guidance on how rendering and rasterization all works with Vulkan than I have with OpenGL. And that isn't to say that the OpenGL stuff isn't clear or bad or anything. It's a lot of it, and the funny part is I was reading about this while I was looking at Vulkan, a lot of it is dated for older versions. And that's throwing me for a loop because I'm getting competing comments about how to handle things. And it isn't competing comments in terms of, oh, this is optimized this way, do it this way, or, you know, this is the way I prefer to do it. It's competing comments of this is the way it's done kind of thing. And it's really kind of irksome when I don't actually know how that area of programming fully works. And I'm still reading through the GLFW stuff. I'm hopeful that the Vulkan stuff will help further demonstrate what I need to do for this. Now, all of that said, the first thing we are going to do is we are going to actually just confirm that Vulkan's installed. I've already done that prior to the stream. That's actually what I was doing in the hour leading up to it. But I have not moved the Vulkan library into our current game engine. So that said, let's go ahead and let's make a start. Alrighty. So really quickly, as you can see, my goals are up there. My goal is then to get the Vulkan renderer working, to make an instance stroke batch renderer for OpenGL, and to get more confidence in the scripting language for shaders from GLFW, and that is known as GLSL, which is, from what I can tell, a sorry, I paused because I just noticed there's a executable file in the bin for Vulkan SDK that is actually called GLSLC. So yeah, it's a C. Sorry, I was gonna say it's a C type language. Yeah. Hey Mimi, would you recommend anyone write their own game engine over just using Unity or Unreal? Yes and no. It depends on what you're trying to do with it, or even Godot. So it really depends on what you're trying to do with it. If you just want to program games, any of those three, any engine out there will do what you want to do. If you're interested in understanding how renderers work or writing your own physics library or what have you, you know, you want, like for me, the reason I'm doing this is I've been programming for a bit, and there are two itches I've had. One is to create my own neural network library, which I've done before. I'm doing parts of that on live stream. I need to get back to that, I realize. The other part of it is I've had an itch to create my own sort of big projects. And this is my sort of white whale in coding. This is I want to feel like I've actually made something of my own. Now, that said, what a lot of people don't realize about Unreal, for example, and I think most people with Unity who've worked with Unity realize this right off the bat, is both engines, and I don't know much about Godot. I've done very little with it. I have worked with it, but I've done very, very, very little. To say I've worked with it is not actually fair. I spent like an hour with it. That's actually not true. I spent like a week with it. But both Unreal and Unity are modular-based engines, and that's something I'm trying to take into my engine, which is to say that if you don't like the renderer, in fact, I've had this conversation with somebody, if you don't like the renderer in Unreal, you can make your own renderer and put it in. So when I work on the RTS stuff, and we were talking about different ways in the Unreal community to handle large-scale unit sets, so having, you know, thousands of units on the screen, somebody said, oh yeah, no, I had to make my own renderer. It took me 6 months to do it, yada, yada, yada. You know, instead of using, say, vertex animations or a different way to instance skeletal meshes, because skeletal meshes under the current renderer systems don't instance correctly. That's actually part of that batch renderer thing I'm talking about, because those are one-to-one draw calls. For every unit, you have one draw call. Actually, you have more than one draw call, but you get the idea. What I'm trying to do is figure out how to create a renderer that I can have multiple draw calls for a skeletal mesh being animated. So, you can actually do that in Unreal. You can take out parts of it and put other parts in. It's all in the project settings. Like, you can switch out their AI system. You can switch out the physics system. And because Unity doesn't have these built in, it's fairly obvious early on that you have to either build these in, get a copy of something, and plug it in, what have you. So a lot of the stuff that, you know, I'm doing here, you can actually, if you looked at the API or the frameworks for Unreal or Unity, you could actually create modules for. In fact, in part of my research for doing this, I actually delved through the open parts of Unity, because Unity isn't completely open source, as we all know, and I've delved through parts of Unreal, which is completely open source. When I was trying to understand how the matrices work for rendering, I actually went to Unreal's matrices, looked at them, and kind of unpacked them. So a lot of this will translate over. All right, really quickly, let's just make sure that VK is working. Sorry, Vulkan is working. And if Vulkan was not working, we wouldn't have this lovely spinning box. This is part of, let me just bring over the bin file. This is part of, folder I meant. This is part of the SDK. And this is the test we're running just to make sure that this works. So there we go. We have our spinning cube. Now, something I forgot to say, let me just go back to the SDK here, is in my includes, you'll notice I have GLM. I have not decided if I am going to actually use GLM or not, because, hey, look right here. We have this matrix H header file. I'm just going to open this in Notepad really quickly because I don't want to accidentally set it up to something. Now, if you look through this, what we're looking at here is something, wow. I actually like how this is set up. We've set up our own matrixing already, so I'm not sure if I want to use this, but I do want to use it for some of the other math functions it has built in, like the trigonomic, oh my god, I can't say that word. The trig math functions it has. I'm not sure what's in common yet. I haven't actually looked through this yet, so yeah. Unreal is an open source and everything is on GitHub. All you have to pay Unity for the source. Godot is, on the other hand, open source, but it's very basic. Doesn't seem like it. So it doesn't seem like making your own engine. Yeah, that's what I was saying earlier. Unreal is completely open source, so I was going through the sorry, not the documentation. I was actually going through the source files in Unreal to work out how they did this. Sorry, I didn't mean to grab the top one. How they did this bit, and also how they did these bits. These files here that I have highlighted, Unreal does in two files. They have a matrix file and a vector file. And I don't mean the F vector. I mean the vec 2, 3, 4. And then the vec 3 is their F vector, by the way, just to be clear. But yeah, that's what I meant when I said I was going through what I could of them for Unity, because it's not open source, and I'm honestly not going to be paying Unity for full access to it. Luca, welcome on in. You did not respond to my last message. I hope it made you cry. For those of you who don't know, Luca is a longtime friend of mine, and an amazing person. Truly, truly amazing. And in fact, Luca, been thinking about you a lot recently, because that thing you did for me a couple of years ago, if you remember the issue when you last saw me, I've been doing for somebody else recently. It's actually why I had the issues the last couple of weeks. Welcome in, Luca. So today, now that we can see that VK or Vulkan, sorry, I'm going to keep saying VK probably. Now that we can see Vulkan's installed, what we're going to do is we're actually going to put this directly into our dependencies. Now, I have the option, instead of doing it this way, of actually moving it into my Visual Studio dependencies. I don't want to do that, because, yeah, it makes packaging this a bit harder. So instead, we're going to leave this open. We're just going to move this to the side of the screen for a moment. And that caused me to lose all my windows for some reason. Don't apologize. Everything is fine, honestly. It's just been a bit hectic trying to make sure that all the things that need to happen. Sorry, I'm just trying to get my dependencies open. So here we have my dependencies for the engine. And we're just going to repeat what we did over here. And all I'm going to do is I'm just going to name this Vulkan. So we have our Vulkan folder. And we're going to repeat the pattern we have in here. We have our libraries. Really should have probably renamed this just as lib to make my life easier. So I'm going to take the include folder. And I'm just going to copy it into here. There we go. There's our include folder. And I'm going to do 64-bit. I was going to say 32 because I'm reading that. But so that means I'm going to ignore the 32-bit library and use this library folder instead. So I'm just going to bring it over to copy it. Good. We now have that in our dependencies. The next step is to actually make our engine. Great, the pterodactyl song is on. Is to make our engine actually include these as a dependency. That's a fairly simple task. I'm going to leave this window off to the side because I'm probably going to need it just to make sure I'm getting the source files correct. But if we pop open our engine here, and in fact, what we're going to do really quickly is we're going to just drop that out because we don't need it right now. If we pop open our dependencies and we hit refresh, we can see that Vulkan is there. That doesn't mean we have direct access to it. Yes, I can actually say include. I can use these long includes I have here, right? That's not that hard to do. But what I can't do is I can't do something like this. And if you go into, say, our, let's go into our Windows, our graphics loader, for example. Here we go. We have these loaded in this way. These are dependencies. So I want to replicate that with OpenGL. So I'm going to go to my Neuron engine here, properties. And in properties, we can see I have my configuration set up. I'm already in Windows 17, Windows 17, C++ 17, which is the setting that we need in order to do this. Now, I'm I have been reading that C++20 isn't fully supported in this version of Visual Studio, which I don't think is true anymore, but we're not going to update to ISO C++20 yet. That will be something I will do down the line, but we do need to stay at standard, at least for modern C++ 17 or newer. For those of you who don't know the numbers, it represents the year in which it was officially released. So C++ 17 was released in 2017. We're currently working on C++ 2023 right now, or 2023. So there'll be another iteration of the standard library in the next year or so. If you're not following that, I do recommend following Bjorn's writings on it, as the father of C++. So yeah. All right. What we need to do is actually link this dependency that we've added in to our engine, right? So to do that, what we're going to do, sorry, I'm just getting some of my notes open. I'm going to leave this in active. Actually, let's go to all configurations for a moment. I just want to see. Give me a second. I should go back to active debug. Oh, it's C++. I'm on the wrong thing. I want to go here. Sorry, I'm just preprocessor linker general. There we go. Am I blind? Ah, there it is. Additional dependencies. Okay. So there's some of our additional dependencies. I'm just gonna go back to, that's what I was looking for. Make sure that's set that way. Okay. Go to general. I'm gonna just go back here for a second. Okay. And finally in our C++ general. All right, so yeah, we're gonna say with all active configurations because it's gonna make my life a little bit easier just to do it this way. Right, so under C++ general and additional libraries, I'm going to include our Vulkan that way. Now, I want the macro for where we're currently at, so I'm actually going to cheat a bit. I'm going to come back to this one in a moment. Sorry, I was just double checking why that was different options. And we're going to go to our linker first. I'm going to come into here. Actually, hang on. Okay. What I'm confused by is I'm only seeing one of my settings, and am I just completely missed where it's supposed to be at? Preprocessor. Okay. Header, output. Ah, sorry. It's this one I was looking for. So we're going to do for this, I'm going to switch this over to all configs. We're going to do it this way. We're going to go into edit from here. And, all right, so we're just going to copy one of these. And I'm going to just hit new. And I'm just going to paste that in there. Now, I'm going to use this last one because we already have the GLFW and the glue ones in there. What we need now is our Vulkan one. So again, I'm just going to open up Vulkan. All right, so that was a little bit smaller than I meant for it to be. Again, you can see that we're following that macro of the solution. So our solution is stored in Neuron Engine, then the folder dependencies. And now we need, instead of GLFW here, we want the word Vulkan. So I'm just going to do insert really quickly. Actually, I'm not. I'm going to just do Vulkan. And I pushed on my dog stepped on a bee remix. and ended up here. How interesting. I just have comments on that yeah. So there we are, and in here we have an include. Okay, and then here we need the library directory. Now, one thing I'm going to very quickly do before we go any further forward is actually go into our library and see what our options are. So I think this is, yeah, this is, we're using CMake. We're not using CMake yet. I've seen a few tutorials out there and a few documents saying use CMake. You know, give me a second. I just want to organize this by size. I don't know if any of these are pre-compiled headers or not. So, we're going to find out the fun way. The Mega Pint remix was actually good, to be fair. I have no idea what you're on about, my friend. There we go. Okay, so we're going to use this one here. And what we're going to do here is, of course, this will be Vulkan. And the last one, of course, will be lib for library or library. And I'm just going to be really paranoid about something really quickly. I'm going to go back to glue here. It is lowercase here, so this is uppercase. So we are going to just keep the case uppercase here. I could just rename the file and make my life easier, but meh. All right, I'm just going to apply that really quickly. So we now should have access to those particular libraries. Now, I'm going to be a bit paranoid. I'm going to follow the guidance from the Vulkan thingamajigger as well. And we're going to go to C++. We're going to go to General. And we're going to go to input, actually. Sorry, not general. And that's not under this. It's under linker. Right. So this is the last bit we need to do. We need to actually say which library are we included. I have no idea why it's done this. Why it's actually put the additional dependencies in as all of this. But what have you. I'm not worried about that too much. So we need to find the library file that we're using, and in here, let's go into here. We're looking for, I believe, yep, it's the Vulk1 library. So we're just going to take that name and paste it on into there. The other one we might need is the GLM library, which I might have to do separately. I'm not entirely sure. All right, I think I have it set up. I don't know. We're gonna find out the fun way, I guess. Right. Let's go ahead and apply that. Close it out. And I just really quickly, I'm going to just make sure that we have no errors by building. We already knew about that error. We'll tackle that later on. Okay, I'm not seeing anything new. Let's go ahead and just hit play. All right, so that's still working. What's concerning is... Oh, sorry, I skipped something. So we've done that part now. Now what we're going to do is create a simple set of code that we can use in order to see that this is working. Now, really, really simple. I'm just going to create a new void above the stream test there, because that, again, is meant to be copied into it. So this will be our Vulkan init test just to make sure that Vulkan is working. Let's go ahead and actually call that down here. So what we're going to do here is we're going to create a new instance of a GLFW window. So we'll do GLFW init. And actually, before we do this, I just want to double check something. I think we already do this elsewhere, and I don't want to repeat efforts here. I don't want this copy of it. Okay, I forgot it's going to search the dependencies. Right, if it's anywhere, it's going to be inside of our window. Sorry, not the header file. I'm looking for the act. You know, let's make my life a bit easier. There we go. Okay, so when we create our window, we do our GLFW and init stuff in here, it looks like. I'm just double checking. Yeah, we have, we run init. In there, we do our GLFW and init. Cool. So we actually don't need that. We can use what we did earlier in terms of this. In fact, I'm actually going to take all of this for a moment and paste it into here. Okay. So, just give me a second. I'm going to bring this over here so I can look up something. GLFW window hint. And we're going to take a look at what this one does really quickly. Set specified window, hint desired. That's useful. The function sets hints for the next call to GLFW create window. The hints, once set, retain their values unchanged by a call or function until the library is terminated. I'm going to skip that one for now. So next we're going to do an unsigned 32-bit character, 32-bit integer, and we'll call this extension count, and we'll initialize it out to 0 for now. And then we're going to do vk. Oh, sorry. I'm actually going to do something a bit different. I forgot something very, very important. I'm going to actually include some includes in here because I'm not entirely sure how this is going to work. I want to have them separated out. So, you know what? No, ignore what I'm saying. We're actually going to have them up here. I'm just going to drop them down a couple of lines. So, we'll do include and let's see. I believe Windows. I'm just going to open up my launcher here, or Windows loader. We're loading an FGFW there. We don't need that. Cool. What we do need, however, might be our GLM. Oh, wow. That actually is in there. Cool. And we're going to take vec4 for now. And then we'll include GLM. Why are you giving me such a hard time with the include there? Come on, GLM. And we want our mat 4x4. Okay. And we're going to include 3 define. So we're going to define. I'm not sure what's going on with my keyboard today. I'm almost tempted to switch over to the UK keyboard I have sitting on that chair back there. I will do GLFW include Vulkan. We'll do define GLM force radians. We'll do define, and this one will be GLM force depth to 0 to 1. Okay, So I think we have everything we need. We have GLFW for the window. We have GLM for the matrices we'll be using for this test. We have our defines ready to go. Think I have everything in there that we need. Big question is it everything we actually do need or not? That's a different story. All right. Okay, that's all good. What I am going to include the hint one here really quickly. And we're going to do GLFW. Sorry, hang on. GLFW window hint. And we'll do GLFW client API. GLFW comma or underscore no API. And I'm just gonna make a quick note to myself. This is for the Vulkan test. Cool. All right. How's everyone doing today, by the way? All right, so we have that done, and then we're gonna do a VK. Enumerate instance extension properties. Okay, why am I not being able to access this? I know that the first argument is a null pointer. I know it's then a reference to my extension count, and then another null pointer. Okay. Just want to quickly try something here, just to see something. I'm just gonna bring this over to window just for a moment. Yeah, I know extension count doesn't exist. Right. Just really quickly include, and then I'm gonna look for Vulkan, and we want assuming it's this one. Yeah, there we go. Okay. I was like, I feel like I'm skipping something. Vulkan's definitely missing. Cool. We want to make sure this actually has worked. So we're going to actually output the number of extensions we have. So we're going to do a cout. And this will be extensions supported. And then we'll push into that our extension count. And again, because we want to be a bit agnostic, we'll use endline instead of stroke n. And then let's just make sure this works so far. Just make sure that we're getting something on screen. Better now that the cold is kind of gone. Not gone, because winter. It's but it's not freezing cold. Can I point out that you live in a country that is boiling all the time? Now, what I'm concerned by is I never created the window. However, I'm going to just pop over to our engine. I'm going to go into our logs folder, and today is the 18th, isn't it? The shit. Did I skip a step? I skipped a step, didn't I? All right. I'm taking all of this for now. I'm actually going to drop this under there. There we go. Okay, what I'm concerned by is we're definitely not getting a window here. So let's pop over to our logs. What is... Shit, I didn't mean to close that. Give me a second. Does it ever snow in your country, Luca? Ever? Like where you live, that is. I know like the certain parts will, but Ba-bum, ba-ba-ba-bum, ba-bum, bum, 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 bum. Cool. There's the log file. That's what I'm looking for. All right. Have I forgotten to call this thing? All right. We're just gonna put a breakpoint there because I don't know what's going on. Am I? Okay. I'm gonna put a breakpoint there. Huh. The breakpoint currently will not currently be hit. Cool. Good to know. I'm going to take all of this for a moment as well. We're going to delete a good chunk of that just in a moment. But let's get this in here. Let's get rid of all of this for now. I don't need any of that either. All right, let's just make sure that window actually loads. Yeah, that is definitely concerning to me. Right. What have I cocked up? We have frost here in Sao Paulo. The last time I saw one in Sao Paulo was more like 20 years ago, thankfully. Oh, you need to get used to the cold. Why are you not being called? Yeah, okay. I saw the error pop up there. I don't know why that's not being called. Or be out. What we actually started to get here were tornado formations for the last few years. So thanks to global warming, no frost, but tornadoes. Sorry for anyone who I just deafened. You know, I had all of that growing up. I didn't have earthquakes, but I had tornadoes. I had thunderstorms that actually, you know, were nice to look at. Boiling summers, freezing winters, no season known as spring, a really weird season known as fall that lasted like a week before we went into just a frost. Right, just for a moment, what I'm going to do is just comment this out. Interesting. Right. Let's get some working code up here really quickly just to make sure that I haven't done something really stupid. Huh. That is concerning. All right, so we failed to load glue for some reason. Wait, did I say failed to init glue or no? It's GFW. Just gonna get rid of that for a moment. Okay. So our 2D renderer is working fine until we try to use this bit. Fair enough. Let's skip that bit then for now. If we need to put it back in, I'll work out a solution for that. Oh, son of a... All right, that's clearly why that wasn't working. I'll undo that line in just a moment. Okay, so we have 0 extensions supported right now. But hey, our window loaded. Cool. Let's go back here just for a moment. I'll probably put an if in there for when that actually loads. All right, we're going to get that GLFW error or glue error again, where glue failed to load. Yeah, failed to load glue. Cool. Let's skip that for just a moment. Okay. So when we're doing, when we're doing this, we don't need that. Okay. Cool. Good to know. I'm also going to move this into here now. Do this at the top. Okay. Hit play. Here we are. So that seemed to load in glue correctly. Or not, because it's 1313 right now. Let's just do another one. It's 1313 still, so if we see two 1313s, we know, hey, something's gone sideways. I'm not entirely sure we need... Okay, that must be the last one. So, yeah, it needs to be there. And just really quickly, just to make sure I didn't cock the other one up, that we do know is working. Let's run that, and there we are. We're tracking our mouse still. Okay, cool. Can you resize your font? It's hard to read on mobile. I mean, I can do that and make it bigger that way, but it gets a bit trickier for me to see, unfortunately. How zoomed in can I get? I like how pixelated these look now. Jesus. This is 386% zoomed in. Let's go to 400 to see what that looks like. There's 400%. I actually can't read this easily. Holy crap. Sorry to laugh, but that is actually really hard for me to read. I'm going to say at 273 for now. Right. So, yeah, but not envying you on the tornado in winter. You know what? It was fun playing in the snow. I recreated the Battle of Hoth a lot as a kid. I had an AT-AT toy even. Okay, so... Give me a second. I'm just gonna check something. Okay. So yeah, we're running update there. Yay. We have our terminate built into the destructor. Yes, we do. Do I actually do GLF destroy window ever? GLF destroy? No, I don't. Cool. So really quickly, I do want to add that into our destructor while I'm thinking about it. And that will be GLFW destroy window. And we're going to pass in this as the window we're destroying. What we'll do actually is get instance. We'll use this macro I created of get instance. And we're going to pass in for that this. I think that's how I did that. Target window. Really? Really? You're going to give me that hard of a time? Window ref. Cool. Is it just window underscore? It is. Cool. All right, so there we go. Okay. Really quickly, I'm just going to run that again. Make sure we get no random errors. Cool. We don't. Close that out. Close that out. Let's go to our log file. Make sure there's nothing. There we go. We are loading things in properly. Cool. That's what I wanted to see. Ba-bum. So, day at the beach, tanning until we get blisters, drinking nasty seawater, sand all over. I mean, the seawater is better than the Florida seawater I found, which is surprising. Also, so that thing I told you about where the last couple of weeks where I've been dealing with that life or death situation, quite literally life or death, that isn't a figure of speech in this case. I actually referenced coconut water because they needed something. And all I could think about was, I prefer drinking it directly from the coconut. And I was just imagining, I can't remember the name of the beach at Jacapaguar, near where, you know, who lived. Man, they had really, really good, coconut water. Sorry, I couldn't think of the word coconut for a second. I was like, it's a thing I just said. Why can't I remember what it's called? Okay, so now that we've done that, we're gonna just run a quick test. And we just want to make sure that the GLM stuff is actually working. So let's go back to main. Actually, I can do one more test before I do that. Let me just drop that out really quickly. Make sure that's still loading correctly with the small changes we made. There are no bugs on closing it out. So the destructor that we've updated is working correctly. I just got paranoid that something in the destructor was going to go wonky. Cool. So let's do our test really quickly. And we're going to do GLM. And we want mat4, matrix 4. We're going to call this matrix. And then we're going to do a GLM vec4, which we will call vector. And then we're going to do an auto, because I have no idea what this actually is going to be, of test. And that's going to be equal to matrix. And we're just testing that the math library that we've installed works. It's going to be a vec4. Cool. Let's just make sure this works. We aren't getting thrown any random errors. Cool. So what is concerning is this shouldn't be 0 right now. So I just want to go back to our linker and make sure that I've set everything up correctly. All right, so we need Vulkan 1 library or .lib. We need GFW3.lib. I'm just going to pop this open for a second, and I'm going to copy part of this. So I'm going to copy this line in particular, and I'm going to go back to my I'm going to go back to C++ general. And just in case this is for some reason being really finicky on me, we're going to add new. And yeah. Okay. We're going to apply that. That should automatically include GLM as well. Actually, hang on. I'm going to undo that. I just realized I made a mistake. So I'm going to delete this one. Cool. I don't know why that's being weird. Give me a second. Properties. Okay. There we go. Let's go back to have nothing in there. I put something in here that I put in the wrong window. I think I did at least. Wait, is it in here? Oh. Yeah, that's why it's not working. Make sure this actually runs. Okay. And there we are. We have our supported extensions. That's what we're looking for. Okay. Whew. That was a bit nerve-wracking there for a second. We drink directly from the coconuts everywhere here. I recommend the experience. I agree. Honestly, it tastes so much better. It tastes less processed. Also, a lot of the coconut waters I can find in the UK are definitely artificial as all get out. Yeah, I was about to swear there. I recommend the experience. However, you need to be a pro to open the freaking coconut without chopping a finger off. I will say, watching people with machetes just cracking a coconut was damn impressive. Especially if they could do it in the fewer hits they could do it in, the more impressive. Because, like, you'd watch them turn it around and, like, just knock off the top of it. And a few of them would take a couple of, when I say knock off the top of it, I mean the outer layer. And then a few would take a few hits to actually get through the inner part to open it up. Some would just stab directly down after getting the top part off to open it up. And then some would cut straight through. Like, just watching the ones cut straight through was pretty damn impressive. All right, so we have our Vulkan extensions now working. What we're going to do next is cry for 5 minutes. Because, yeah. So, I'm not sure if you guys can hear that, but man. Now my window is fully closed. Jesus, that is loud. Sorry, I'm hearing the wind. Why is the word fish in that, Luca? Sorry, I just saw that. Got a watermelon for your friend and make watermelon juice. Funny part is, seriously, I shit you not, the last time I saw them, that is what they did. They literally did that. Yeah, they did it impressively fast, and and not even look at the coconut crazy skills. Oh yeah, the fact that my hair is like a foot long now. When my hair is down, it goes to the small of my back, ladies and gentlemen. Yes. For those of you who don't know, I'm growing my hair out for Locks of Love. Not Locks of Love, that's the US version. I'm growing my hair out for the Princess Trust, which is same as Locks of Love in the US. So when my hair is long enough, I will be cutting it to donate it for children who have cancer to make wigs out of my hair. So I will be actually doing a fundraising event for that charity and Macmillan, which is a cancer charity and a health charity in general, when we get to that stage where my hair is getting long enough to do that. So keep in mind that I will be donating my hair hopefully in the next couple of months, because, oh my god, long hair is a nightmare to wash. All right, so now that we've done this, I don't need this anymore. We're done with it. We're going to do probably another test one, and then I'll figure out how I'm going to create the class from that. So let's do void, and this will just be Vulkan test. No, it won't. We're not going to do it this way. Yes, my elbow just missed the table, and I went down with it for a second. Give me a second. I want to replicate how I did my Windows tests. And I'm going to just look at here for a moment just to... Sorry, I do need to zoom this out so I can read it in its entirety. I don't know what I'm doing right now. Oh, fine. I'll show my hair off. Give me a second. It's going to take me a moment because... Oh. You know, the one thing I really hate is removing the hair tie. All right, I actually have to take the headset off to do this. So, yeah, I go full Jesus. Yeah, it's actually curly, so I had to pull it straight so you can see how long it is. But once it's wet, like literally when the water is holding it down, I can go Cousin It too. There you go. Full Cousin It style approach to this. And you can still see my face. Give me a second. God, I can smell my shampoo. There we go. Can also smell a cigarette from last week. Yeah, again, you can see it's curly, but right now my hand where my hair is ending is right at my belly button. Actually, it's just below my belly button. So yeah. There is the Cousin It look. Let's go back to being Jesus for a moment. And there is the full-on Jesus look. I look like the girl from the Ring movie. My hair's not dark enough yet. My hair used to be darker, actually. So yeah, there you go. So I didn't even hit the mic when I did that. Or emo rock kid from the 90s. I prefer the term goth kid. Because first off, emo wasn't around until the aughts. It was goth at that point in grunge. Not entirely sure what the difference between the two are anymore, but yeah. So I bring the hair tie back in so I can put the headset back on. Oh, I just knotted my hair up instead of actually putting it into the tie. Oh, I have a lot more respect. Definitely just yank some hair out. There we go. Oh, that really hurt. I definitely have a lot more respect for people who have to, wash long hair, because my showers went from like 5 minutes to like an hour, and I will tell you about 40 of those minutes are literally just spent getting my hair wet enough to wash it. My hair is also really, really thick, as you know. I say as you know because me and Luca have met a couple of times in person. I spent time at their place I lived at their place for a week, 2 weeks with her and her husband, and she's lived at mine for a week with me after some stuff. Have I never shown you that picture, Luca? If I've never shown you that picture, I'm going to find that picture to show it to you. I'm sure my parents will have a copy of it somewhere. I was a proper goth boy growing up. Right, I could do this in main. I could very easily do what I want to do in main, but I'm not sure that is actually how I want to do it. Honestly, I'm just thinking about the, oh, it's 2 weeks both times. Okay, I can't remember if it was 2 weeks or not. Because I was in Brazil for, what, a month? 2 weeks down in Rio de Janeiro, and then 2 weeks in Sao Paulo. Do it so we can see it work and do it better the way after. That's the thing. I'm not entirely sure what makes the most sense in terms of the actual test version, because all I'm doing right now is testing how to set this up. All right, I'm loath to do what I'm about to do, but it's the only way I can think of doing it right now. We're gonna create a header file. Actually, you know what? Screw it. We're gonna create a class. We're just gonna do a class because it'll be easier. We're not gonna drop it anywhere. This is gonna be our Vulkan test class. Because if I know what I'm doing. Did you only give me the header? Really? Oh, there's the right above it. I'm blind as a bat. Cool. Right. We're gonna drop this into our namespace as usual. So, namespace, Neuron Engine, graphics. Boink. It is. I'm just gonna copy this just to make sure I haven't typoed because I'm always paranoid. Boink. And then for now we'll use using namespace. Okay. Using namespace. There we go. Right. I don't think we're going to need a constructor for this, so we're going to start with our methods. And where is my Windows header? There we go. Grab that. All right, so let's start with our public methods, and we'll do a void called run. And then we have our private methods, which will be void init Vulkan. Void what did I call it here? I gave it a name here. Also, please for the love of God, go over there. A init. Actually, I'm just going to name it init instead of init Vulkan because it keeps my standard. Otherwise, this would be init window, init GFW. Actually, I think that is what GFW is called. Update. Yeah, we'll call this update for now. If we need to change that, we will. So I'm just taking a note of where it should be running. Otherwise, I'm gonna have to do something else. Void, and we're gonna have one called cleanup as well that will be run on and the destruction of our thing. Cool. Right, let's pop over to, let's grab all of these really quickly. And just drop them in here. Let's get rid of this stuff. Cool. There we go. So we have, we've declared them. Now let's go ahead and define these suckers. All right. You know what would be useful, by the way, before we went any further? Something really, really important that I totally forgot to include my includes. So, we'll do include Vulkan, and then we want Vulkan header. Include, and then we're going to do our graphics. Actually, we don't need glue, so we're not going to do our graphics launcher. We just need GLFW. So GLFW, and then we'll take GLFW3. And I'm going to take the define I did in here, actually. I want GFW include Vulkan. Cool. All right. So what we're really doing is we're taking everything we've done in when we're creating our renderer by hand here, and instead of doing it by hand here, we're going to do it in the Vulkan system. That's because it doesn't have a standalone one, which is why I got confused on where I was going to put it. Definitely going to be copying this code over at some other point and moving it into the correct spot. But yeah, this is roughly where we want to go with it. So we want to create our system separately from the window itself. We don't need to, we don't need to hand make our windows like we do with our 2D renderer, where we're going through all this. We still do, but we're going to be using Vulkan to do it for us. We aren't going to be doing it in a separate process. Sorry, I'm just checking something on the Vulkan API. Actually, we're going to call this window loop. And that means we're going to go back over here. And we're going to change this to window loop. Also, we're going to go back here and grab the scope. Because, yikes, I forgot that. Sorry, I'm also going to look at this for a minute. Actually, we're going to rename this because we need to create a window in there. We'll call this init Vulkan. And then we're going to do void init window as well. Actually, I'm just going to take the init window. Paste that there for a minute. Grab the init Vulkan. Yeah, I could have used the rename features, I realize. And grab that bit. There we go. Okay. So for the window, that's going to be really simple. I'm just going to move this to the other side of my setup here. I'm going to lose a chat for a moment, folks, just as a heads up. And what we want to do is we want to do... Actually, we're going to do this as a bool. We want to return something off of this. So, actually, you know what? No, we're going to not cheat. Actually, no, I was right. We are going to do it this way. We can talk about reducing this later on and talk about polymorphic encapsulation later on. But right now, we need to make sure that GLFW actually initializes, that is. So I'm just going to copy the code from the GLFW stuff. Oh, yeah. Oh, eat me. Sorry, that was the fact I have to include IO stream. There we go. That should get rid of that error. And I also need to include our logging tools. So, utilities, headers, Ustream. That includes our logging tools for our output there. All right. Sorry, let me just move this back. That is not what I wanted to do. Okay, cool. That was not the window I thought I had grabbed. I thought I had grabbed this window. Anyway, so I just taken that bit there. Right. So we'll create member methods for height and width. So let's just grab that. We're actually going to grab all of this. Okay. So clearly we need a reference to window, height, and width. So hey, you know what? It's all here. So we have our height, width, and we have window. So I'm just going to grab... I'm actually going to grab all of this for now. Yeah, I actually don't agree with what I'm doing. At all. I don't like what I'm doing. First off, these are in the wrong order. We want these in the order in which they're actually going to be used. Let's move them around a bit because we need the window before we can do this. Sorry, I'm literally just thinking in my head as I work on this how I want this to look. All right, so what we're going to do is if, and then init window. If that is true, then we are going to init Vulkan. Right. I'm not entirely sure any of this is what I'm going to keep around. So, I am going to build a constructor for this, actually. I lied. Let me just grab that comment there. And of course, this will be in the public scope. And this is going to be Vulkan test. And I definitely know I'm going to need certain elements, but we'll talk about that in a moment. In fact, just to be on the safe side, I'm going to create a destructor as well. Okay, let me grab both of these now. Come back here. Paste them in, grab that. All right. Now, I'm not entirely sure we need to run at the end of the day. That's why I'm moving that around. Okay, give me a second. Let me just drag this back in here because I'm not going to do what I said I was going to do a moment ago. I am going to do what we're doing in here, however. And we're going to create our window that way. So, I'm just trying to think about what parts I need to move from here into there and what parts I need to keep where they're at. So Vulcans are going to take in an argument of int. So int width, int height. Okay. Let's just go back here for a moment. We are going to need the Windows header. So yeah, what I'm trying to do is, all we're doing right now is trying to recreate this system inside the Vulkan system. So all I'm doing is trying to determine if, to be fair, I'm not entirely sure what I'm trying to determine right now. First off, I'm just going to delete this. This is going to go back to being void for now. So we're back at where we started. Yes, I know there's an error. Give me a second. There we go. So currently, we have a working renderer. We have to hand do that renderer, and it's not as performant as the Vulkan renderer. And this is just the OpenGL renderer. So when we run this, what's happening, give me a second to find the errors. Yeah. We don't need that anymore. Sorry, for anyone who doesn't recognize that error, that's why we created the graphics loader. Glue has to be loaded in before GLFW3 is loaded in, otherwise it freaks out at you. So I don't need to have that in because Window actually has that loader as part of it. So anything that's using the window, I have expected, incorrectly or correctly, incorrectly in this case, to include both Glue and GLFW. So currently right now, ooh, what the fudge monkeys. Oh. Yeah, that's no longer a bool. There we go. So currently when we load this up and we have this printed, what we're looking at is 3 2D objects being individually rendered. So you have the red one here, we have this purplish one here, and this blue one here. Each of these, well, let's call them sprites for now. Each of these sprites is being individually rendered by our renderer, which is not performant. They're the same thing. The only difference is there's a color difference. That's what I'm talking about with the second goal with the instance versus instance stroke batch renderer. So we don't have this the amount of draw calls we're pulling here. Now, to be fair, with only 3, not a huge deal, but when you add more into the game, it becomes more problematic. Now, DirectX and OpenGL, while both phenomenally useful tools for rendering and rasterization and creating images we have on the screen, aren't actually the best out there. And case in point, Unreal's written their own. Vulkan exists, OpenGL. I mean, all these things are doing the same thing. OpenGL, DirectX, Vulkan, whatever the heck Epic is currently using in their stuff. I can't remember the name of it. They all are doing the same thing. They're all going about it different ways. And in some cases, one way is better than another. And in other cases, that one way that was better before is actually worse. And sorry for the loud can. Yes, I'm speaking of watermelon, Luca. Watermelon monster. Quadri, for this one, there isn't a repo, not yet, not until this project is done, because I will be, if you're interested in working on the project, if you join our Discord server, link in the description below. We are looking for more people to join us on this project, to help work on it, to help design this engine, and all that fun, fine stuff. But until it's done, I am leaving it as a private repo, just so I don't have to worry about managing it too much. So, Luke, as I was saying, in some cases, the way in which you render an image for one game or one project makes sense, but for another project or another game, it doesn't. You know, take a first-person shooter versus a third-person game, top-down RPG or RTS style game. The way in which the units, the characters on screen, the objects are rendered, and the amount of draw calls they have is going to be vastly different. With a traditional first-person shooter, yeah, it makes sense that each character is a single draw call. But when you're looking at a top-down, say, RTS style, well, all the units are usually in a group doing the same thing. Marching, attacking, shooting arrows, what have you, or shooting guns, what have you. And you don't want to have one draw call for each of the characters, especially if you have thousands of characters on screen. You'd want them to share one draw call if possible. So I'm looking at methodologies to achieve a more performant draw call for that sort of situation. Now, my goal, and I'm not sure if you were here when I mentioned this at the start of the stream, my goal with this engine is a modular engine. So I want, 2 to 3 renderers in this engine, and for the ability to switch between them based on what the game design is going to be. So if it's going to be first person, hey, DirectX is great. If it's going to be third person, top down, I'm actually probably going to go with Vulkan. And the reason why I'm going to go with Vulkan is Baldur's Gate 3. I've had better experiences, or less technical glitches, in Baldur's Gate 3 with Vulkan than I have in DirectX. Now, that was the reason I started looking into it. I looked further into it and found that there are a lot of optimization things that work in Vulkan. Now, that don't work in DirectX. Now, the only downside of Vulkan is that Vulkan isn't as user-friendly. Please notice the air quotes with my fingers, as, say, DirectX is. So that's why I've opted. That's why I started, or OpenGL even. So that's why I opted to work with OpenGL first. Not to mention everyone saying doing your own game engine, start with OpenGL. Which, to be fair, is fine, but I just need to try something a bit different just to test sort of my own understanding of the material and to expand on what I believe I know about this process. Also, I need to make sure I don't reverse my height and width. Quadri, what are those question marks too? I responded to your question earlier. Did you not hear my response? Also, welcome in, by the way. If you didn't hear my response, that's fine. I can repeat what I said, but yeah. Also, do remember there's a bit of a lag between the chat and me. So if that question marks is something else, fair enough. Just let me know what's in relation to, because I don't know when you posted that or what you were hearing when you posted that. So just let me know, and I will try to explain anything that I can or restate anything that I've already stated. So let me just pop back over to main, because we want to go back to using our Vulkan setup here. So, all right, I am actually going to move main off to the side for a moment, because what I'm going to do, you know what? We're going to do it that way. That way I can do, oh, you know what? I hate doing this when I'm live streaming, but there we go. We're going to do it that way. That is just going to be easier on my eyes and my brain. Right. Oh, all this is open stuff. Like all of the, like, OpenGL, GLFW, which is part of OpenGL. Glue is all open. Vulkan is open as well, and so is DirectX for the most part. Yes, that's what I meant. That's what I was saying earlier. Vulkan is not as quote-unquote user-friendly as OpenGL. If I said the reverse earlier, I apologize. To be very clear to anyone watching this as a VOD, Vulkan is harder than OpenGL. It has less things built into it, like input. Whereas with OpenGL, you can use, say, GLFW and Glue to get, well, Glue is about the graphics more than anything. With the GLFW, you get the window, input control, etc. Vulkan, I'm using GLFW to get around what it's missing. So yeah, Quadri, if I said that backwards, sorry, I meant to say that Vulkan is less user-friendly than OpenGL. Right, so sorry, I'm just thinking again. All right, so like I said, OpenGL and Vulkan. This be how. So anytime you see main window, by the way, that's GLFW with OpenGL. Anytime you see GLM or VK, of course, that's going to be the Vulkan. Sorry, I couldn't remember which one I had just said. Wow. Give me a moment before I continue with what I'm about to do here, because I might want to load this in differently. I'm going to go back to window. And really quickly, I want to see what that error message I was getting earlier was with Glue, because I know Glue is going to be wonky. Oh. Okay. Okay. I guess my concern that I was having from earlier is irrelevant. All right. I am going to tackle this a very different way than I'm currently doing. So sorry about that. Like I said, I'm learning Vulkan as I'm doing this. We're going to put this in our renderer for now. If I need to move it, I'll move it. So we'll add our we're going to call this Vulkan base for now. I will do the same in here. And we'll create a class file for it, or implementation file. Okay, pop that over here for just a moment. Seriously? Thank you. And then include okay. And I am actually going to take all of that because, yeah. Right, and we'll take the namespace as well. And in this case, sad how many files up that was. Right, this can all get, we're just going to delete the Vulkan test that we created. Delete. Okay, cool. Right, class Vulkan base. All right. So in this class, I know I'm going to need a we're gonna do void init. So this will be our function for initializing it. We're going to do void create instance, which will be create our Vulkan instance itself. All right, let's start with these two. Also, let me just grab this really quickly. And we're going to do using namespace. And then we're going to do void init. Sorry, of course I skipped the Vulkan base bit there. And then void create instance. Okay, so create instance. We need access to the VK application info. So yeah, I'm not going to do the instance. I'm not going to do determining graphics cards yet. That will be probably down the line. Sorry about that. We'll do VK application info. There we go. And we're going to call this VK data. Okay. And then we'll do VK data dot S type. And then we're going to do VK structure type. I know it's being caps. Hang on, I'm just going to do in caps to make my life easier. Structure type application. And then it should be info. Okay, there we go. Next we'll do VK data dot P application name. And we're going to just call this application, oh God, I'm joking. We're going to call this Vulkan test. I'm laughing at my own joke of please update. This is similar to the Neuron window thing we have, or Neuron engine thing we have in the other window. So yeah, all we're doing is setting the members of this particular structure. Sorry, I'm just looking at the API for Vulkan really quickly because I can't remember the name of the elements in this structure. All right. Don't know if we actually need this, but I'm gonna try to fill in all of these. So it's gonna be vk data dot application version. We'll do next, and this will be vk make version. API version comes next, I think. So 0 0. Okay, then we'll do vk data dot API version, which will then do vk API version. I guess we're going to start with that one for now. Just I'm picking the simplest version because I don't know what I'm doing with this. And then we'll do our vk data dot, what the heck just happened there? vk data dot p engine name, which I'm just going to set to be Neuron Engine because that's what we're working in, allegedly. And then we're going to do vk data dot engine version. You know what? I'm renaming this as oh, it is an uppercase V. Sorry. Engine version. Really? vk data dot engine. There we go. Oh, it's Pascal, not Camel. Sorry, it's Camel, not Pascal, like I do. And this will be vk engine version make version, and we're just going to stick with this for now. In fact, actually, I'm going to move this line up here. There we go. And I'm also going to move this line up here. Okay. Right. Sorry, my leg is killing me, thus I'm shifting in my seat. So all we're doing is setting the structure for this VK application info. Okay. Now, I'm just going to make a note to myself above this because this is an optional structure. At least I think it is, based on what I'm reading from the Vulkan documentation I have. And then we have a mandatory struct that comes next. And this mandatory struct is used to tell the Vulkan driver which global extensions we want to use and which validation layers we want to use. So this is tripping me out just slightly in my own head here. Also, seriously? Thank you. So say, why are you still giving me an error message on that side? So we have to do VK instance create info. There we go. And we're going to call this, we're just going to call this create info because I don't know what else to call it. Again, it's a structure. And we're going to do here in create info is we are going to do our S type. So what we're doing for S type is, I'm just going to follow the guidance. I'm putting this together, is structure, instance, create info. So we're creating the info that we need, and we're going to store that info in our VK data up here. So the next one we have, we're going to have to pass in as a reference. So let's take our create info, and we're going to do p application info. So this is the info up there, and we're passing that information in as a structure, as a reference, as I said. I also think I reversed what I said. We're storing the information in here. No, we're passing this reference into here. And that's VK data. Okay. Right. Well, I guess this should create instance. That'd be useful. I actually did that. Sorry, I am literally just thinking about what this documentation is saying about these structures, and I'm trying to make sure I've understood it correctly, because I have no idea. All right. I think I have. Okay. So what we're going to do now is come back to our main just for a moment, because I'm going to be cheeky and lazy. I don't need glue open. I want this open. I'm actually not sure if I'm going to use this header now or not, now that I'm thinking about this for a second. But what I am going to do is I'm going to take this line, this GFW hint line here. I'm just going to drop it into here for now. Okay, there we go. Did load in. Thank God. I was waiting for an error to show up. And I'm going to take this as well. I'm not sure why I'm doing it that way. I can just do it this way. And right, I'm going to make a const character array reference, or pointer, I guess, not reference. All right, and this will be extensions. Sorry, I was just thinking about the name up there. All right. So then for extensions, what we'll do is we're going to set this to be glfw get required instance extensions, and then we're going to pass into that our extension count as a reference. Of course, I guess it would be helpful if I was actually passing in the correct variable or setting the correct variable there. Otherwise, you run into issues of it going, this thing doesn't exist. All right. So from there, what we're going to do is take that comes back from that and store it in create info in our enabled extension count, and that will be our extension. Oh my God. There we go. And then we will do our create info, and then we want our extension names, and this will be, of course, our extensions. Okay. So I'm not sure if VK does VK require layers for a test. Vulkan layers requirement. So let me just bring over what I'm Googling here. While most developers will already use variations, profiling, debugging, your own layers. Yeah, right now I really don't care about my own layers. I'm going to want a 3D layer, a UI layer, and a debug layer. I have the lurking feeling as I'm looking at these figures that layer means something different to me. I hate JSON. Here we go. I'm looking at the VK create instance here. VK create instance is initialization. It's where we get our initialization and construct our dispatch table. Even if your layer doesn't care about the instance itself, this is still where you need to perform your initialization, and it is required that all layers implement this function. Okay, so I still have to do the layer stuff. That's the part I was looking for. Cool. Right. So, because we're required to do that, we're just going to set the layer count to 0, I guess. And I don't know if you saw that the layer count was stored in our create info. And we have enabled layer count. We're just going to set that to 0 for now. And we'll update this down the road. Okay. So now we have everything that we're going to need for the Vulkan system. At least as far as I'm aware reading this documentation. So now we actually need to create the instance. And to do that, what we're going to do is we're going to create a new variable of type VK result. Here we go. And it's an enumeration. So let's take a look at what our... Okay, fine. I'll go to Google then. If you want to make sure you Google it. Hopefully I can get a... So VK result. Here are the outputs we can get. And along with the descriptions of what they mean. We'll come back to that later on though. And we're going to call this, I guess, result. And we'll do VK create instance. And what we need here is the create info. So we have that up there. And we're going to pass that in. It's a pointer, so we're going to pass that reference in of create info. We need our VK allocator callback, which... Do we need that? VK allocator callback. Allocation callback, sorry. VK allocation callback. I'm so glad I did that. I misspelled callback. Oh no, that's not what I wanted. VK, what was it? VK. I'm not in the right version of window of thingamajigger for that. Can you please give me the list of arguments? Thank you. VK allocation callbacks. VK allocations callback. Or allocation singular callbacks. There we go. Okay. VK allocation contain callback function pointers for memory allocation. Okay, we will most likely be needing this down the road. For now, because it's asking for a pointer here, it's a pointer. I'm gonna pass in null for now, or 0. Actually, I'm gonna do null pointer just to be on the safer side and cleaner. And then we need the instance, and have we actually created an instance yet? We haven't. So let's go back to our header here. I'm going to just go back here for a moment. We're going to grab this because I like having my code organized a very particular way. I'm weird like that, I know. Right, just to be on the safe side, this will be public. I kind of want to make this one private, but for now we're going to leave it public. However, we are going to have a private member, which will be VK instance. No, not image. Instance. Really? Really, computer? VK instance. There we go. Which we'll call instance. There we go. And this is what we're going to pass in as a reference. I hit the wrong button. Over here. Okay. So now that we have an instance, we're storing that instance information there. We're getting all this stuff. We're seeing if this actually builds correctly. Yeah, we'll do the allocator callbacks down the road. Mostly because I don't know how to use them. So I'll have to do some reading around them to see what to do with them. All right, so we want to make sure that this is good. So we're going to do next, and I know I could reduce this. I'll come back to reducing that later on. Condense the code, that is. We're going to do an if, and then we're going to do result, because it's an enum. Oh, God, I lost the enum list of... Give me a second. VK result enum. So let's just go back here, and I want to know if this is not succeeded. So VK success. There we go. So if result is not equal to VK success, and for now we're going to do an std cout VK failed to create instance. And then because we're staying agnostic as possible, we'll use an end line. And then we're going to do a Ustream write to log file. And what we're going to write here is literally what we have up there. I will likely be getting rid of this line down the road, of course, because we have that down here. All right. And then... We're going to do this again because of the error we had earlier. And the one we want for this one is related to extensions. Let me get it back on the screen though. Okay, yeah, we want extension because, I mean, we could do a setup for all of this, but for now, I just want this. So if our, actually, I'm going to have a couple of these. In fact, what we're going to do is actually have them in here. And we're going to do a, just, this will go directly into the log. And we're just going to go VK extension not present. So all we're doing here is writing out what errors we could potentially have based on if this does not actually successfully build. And I only really care about a couple of these. So let me just get that back up on my screen. I care about that one. I care about initialization failed. So we'll take that as well. So we'll do result equals that. And again, you know what? Because these are one-line commands, let's not put them in blocks just for this, because all we're doing is outputting an error log. VK Failed initialization. And again, let's just pop back over there, see if there's any other ones that have caught my eye. I don't know what not ready is yet for this. Timeout, not worried about. Event set, yeah, no. Actually, I want this one because I have no idea what I'm doing with the layers in VK yet. So this will save me time when I'm debugging down the road. Else if, and then we're going to do that. And then let's just copy this line. And then I'm just going to do else. Ustream. Right, so log. And I will update that in a moment. So other Vulkan error. Yeah, there was a whole bunch. I don't want to write them all out. It's going to be boring to do on stream. But this is just so I have... These are the three that I'm most concerned about personally. I'm sure somebody else is screaming, oh God, there's other things to be worried about. But right now, while I'm testing the system, getting it built up, these are the three errors I care about most. And this is layer not present. I am going to have... However, one other else here, and I do want to output to my log that VK has actually loaded. So VK loaded, just like I have with my GLFW stuff or glue stuff. We have the glue loaded and then the GLFW stuff loaded, or failed to load in this case because we were testing something. Right, that's all we're doing is we're just having an output log of what's happening. And that is just, again, so I know if I've cocked something up that, hey, this is right. Why am I getting a warning here? Okay, well, get over it, IntelliSense. Sorry, that was IntelliSense complaining that, hey, you're using this thing, and it's not really my choice. It's what's built into the VK result stuff. Right. Actually, what I might do is update the extensions not present one, because there's going to be a lot of extensions not present. Actually, no, what I might do is for the ones that are present, let's say there's a required one here that's glitching out. Because we have a whole bunch of required one and a whole bunch of optional ones. I kind of want to print which optional ones and which required ones have loaded in. So to do that, how am I going to do that? I can create an array of values. All right, so to pull that trick off, we're going to just include vector. And that will be where we're going to store our extensions, or our list of available extensions. So we're going to get a list of extensions, we're storing it there, then we're going to store it in somewhere where we can read it from, so that we as the end user can actually see, or the developer team can see what the extensions are that are loaded in. Right. So I believe there's a function called enumerate extension count. I think I've already used that actually. Yeah, I have. Okay. Did we use it in here too? No, we did not. So what we're gonna do is just like we did over there, we're gonna do that here. We're gonna just gonna plop that there. So say I remember doing that somewhere. Why is this one not freaking out at me like this one is? Unsigned integer, 32-bit. Yep, that's the same. Why do you not like it in here? Oh, we don't have the player name. We have the property count. Yeah, what the shit, yo. Whatever, I'm not so worried about the error right now. That is, or a warning. It's a warning. I'm not so worried about that right now. Okay, so right, I'm not entirely sure how to actually print that to our log yet, so we're gonna see out for now. And what we're gonna do is just create a extension count, and then let's just do this extensions. And then we'll do std end line. Cool. And next what we'll do is for, we're not gonna make any edits, so const. I don't know what this really is. I'm gonna do auto for now. Target extension, because this is a for range loop, or a range base loop. And then I know it's up here. Extensions question mark. Is that what I'm looking for? Oh, wait, shit, I skipped a step. Put this vector thing in, and we actually haven't created the vector that I'm trying to loop through here. So that's why I don't know what this is. Come back to that in just a moment. Let's create the actual vector of these things. So we're actually gonna just quickly extension names. There we go. Okay, and then we're gonna do here std vector, and this will be extension properties, I think is what GLFW exported, extension supported, returns whether a specific extension is available. Nope, that's not what I'm looking for. Okay, it's gonna be VK probably. VK extension properties. What is this? A structure extension properties. Okay. Great. Come on, I wanted to actually peek at that structure. VK extension properties. For now, we're gonna just put that in so I can view the code or peek at the definition. Okay, so it has extension name. That's what I'm looking for. Okay, so yay. Right, so we need to size this. We need to name it first. So we're going to name this extensions. Extension, yeah. We need to size it, and we're going to size it to our count, which we've just defined there. Okay. Sorry, yeah, we've defined it here. We declared it here. We actually are setting it here. You know what? Actually, to be on the safe side, what I'm going to do is I'm going to drop that there. Okay. Now we're going to do our for loop, and I really don't want to look up what that thing was, so I'm going to leave the auto on. Also, we're not changing this. This is a damn reference. And what did I just name this thing? Extensions? Is that what I named it? Yeah, I named it. Oh, do not cut that. Copy it. Thank you. And all we're going to do with this one is we're going to std cout and what we're going to see out is target extension dot extension name. And then we're going to do std end line. Okay. And I'm going to put a destructor in. Now that I'm thinking about this. And a constructor. We are just going to do a default constructor really quickly. So just, whoa, not what I wanted to do. So boink. And then yeah, you know what? Actually, I'm just going to do a destructor. Cool. Let's just quickly do the destructor. So, boink. Right. So in this destructor, because the window already has its memory allocation features put in for destroying itself, let me just double check what I just said there was actually accurate. Yeah, we destroyed their window. We terminate GFW. All we're doing here then is going to terminate the Vulkan extension. So we're going to do VK destroy. I thought that said destroy France for a second. I was like, what the fuck? Instance. There we go. And we're going to pass in, what did I name it? Instance, yeah. And our second argument, well, we don't have an allocator yet, so that's going to be definitely a null pointer still. Okay. So let's go ahead and actually make sure this does something at all. So I am very loath to delete code. We're just going to rename this 01. Oh, that's so bad of me. So very bad. Wait, what do you mean that's not found? It's right up there, dude. Thank you. Okay, now you can be commented out. Because I, again, am very loath to delete code. All right, so we're going to do void Vulkan test. Pop that down there. So all we're doing right now is creating just a simple test to make sure that this works. Now you can tell I always keep my tests around just so I can always refer back to them if I need to look something up or if I need to demonstrate something for the stream. Honestly, it's more for demonstrating stuff for the stream at this point. So, we're going to take all of this. We're going to copy this down here. that part remains the same. We're going to take all of this. And I'm just going to make a comment here. Vulkan. That's just letting me know where I'm going to put all the Vulkan-related stuff that I need to include. All right, let's grab this stuff as well. All right, so this is just running our window. So I'm just gonna make a note, window and input. I'm actually not gonna delete the Vulkan comment. That way I can actually see where things are located. I'm gonna leave that in for now. What we're gonna do is, well, first, we're gonna go back up here and I don't think we need this anymore because we're including that in here. So instead what we're going to do is we're going to do include, and this is under graphics, renderers, headers, and that's Vulkan base that we're going to bring in. And let's just grab it. It is Vulkan base as a class name. Just want to make sure I kept it the same. Cool, I did. That can get minimized. There we go. Vulkan base. Actually, that should be 0, 0, but whatever. We're going to call this Vulkan test, just like we do the shader test. And then we're going to do Vulkan we're actually going to make this a Boolean operator. And the reason why we're doing that is so that we know what's going on here. So if create instance. Actually, we're going to do if fail create instance. And we'll do or destroy there if we fail to create the instance. Right. So Vulkan test. Oh shoot, that's actually a bad name. We're gonna call this Vulkan init test again. There we go. So Vulkan base, just really quickly. Vulkan test. I'm not sure why I had the thingamajiggers on the outside there. Okay. Vulkan test. And then we're going to do dot init. And I'm definitely putting this in private for now because it's going to bug me having access to that. There we go. All right. Moment of truth, ladies and gents. Let's hit play. Make sure that it actually loads in. Okay, it's a bit concerning that this actually isn't populating anything and that the number has gone down to 2. Then again, we aren't actually calling anything else in. We aren't calling in all the stuff we did previously. But let's just go over to our output log and see what we have here. So it's saying that Vulkan has loaded. That's good to see. Now, what I'm concerned by is this isn't actually saying anything. I'm just going to put a breakpoint there for a moment. All right. So it has loaded successfully. Yay. We have 2 extensions. And those are clearly addresses in memory. So really quickly, I need to make a to-do for myself to do Cool. I don't care about roller companions, champions, whatever the flip that was called. Sorry, I'm just looking up something really quickly. GFW get required extensions. Yeah. Okay. Sorry. Sorry for the yawn that is. So what I'm saying here is I need to check if the extensions we're actually seeing here are the ones that JLFW needs, and if not, we are going to return false. So we still want to error out because that is a giant bug if we don't have the stuff we need. Oh shit, no, okay, that's why. Let me just hit continue. Okay. Again, it's concerning that it's not listing anything. So I just want to make sure that it's actually doing something here. The other thing I'm going to do in just a moment is I'm going to go back up to this one. I'm going to grab this bit here. See, again, what's concerning me about this is... Sorry, I was just thinking about this before I moved it over. Do I use hint in here? I do. Okay. Not sure why I had it in there twice. Oh. Lovely. Okay. Interesting. Right. We're going to take this for a moment. We're just going to paste this down here. We're going to get rid of this test thing because we're not doing that clearly. And we want the vector line. Okay. And just gonna come back here and rerun this because why are the accounts different is what's really throwing me for a loop here for a moment. All right, that is genuinely concerning to me. All right, so we're gonna do, let me just go to window for a minute. Also, let's just have these side by side so it makes my life a bit easier. Thanks, Otto. Yeah, you know what we're gonna do is we're gonna do Vulkan. We're just gonna put this all together. In fact, all of this is now going private. So we're gonna tackle this a very different way. Right. Where is my init in here? There it is. All right, for now, we're just gonna do a net in here, which should shut this up about the member variable not being initialized. Okay. Okay. Void create window. Which means I put this in the wrong spot. Oops. There we go. Okay. So void Vulkan base create window. So we're going to move all the methods that we have earlier in main for creating windows when we're using Vulkan into here so that we have direct access to the particular, well, window. All right, we're going to take all of this for now. We're going to copy that into here. But actually, we're going to go down to the other version of this just because, yeah. Boom. Technically, this line no longer works because it's now being done here on the construction. we're going to take the GLFW window hint, and we're going to move this up here. And then, I just want to play around with a few of these. What else do we have? We have, actually, no, we're going to leave that as is for now. Okay. In fact, actually, we are going to change that up a bit. Sorry. What I want to do is create a window. Is that the name of the class? Yeah, window. We're going to create a reference to this window, and this is going to be called window. So we're going to call this main window. There we go. And why are you not happy with that? Okay, there we go. No. Oh, you're gonna be that annoying namespace issue I hate, aren't you? There. Oh, no. Okay, well, hang on. We're just gonna move these variables over here, see if we can get around this error this way. All right, and wait, what? Why is that not working? Okay. Oh, no, it isn't. Okay. Cool. Do it this way. Create new, and then we'll move from there. No operand types are neuron engine graphics window equals neuron engine graphics window pointer. And then here, what we're going to do is destroy main window. Wait. What am I thinking of? It's not destroy. Is it? Oh my god, why am I blinking on basic C++? Oh my god, I'm blinking on basic C++. Delete. It's delete. No, not delete. Why am I blinking on basic C++? This is really kind of sad. I'm cheating, by the way, by opening this up. It's on the vertex buffer. Yeah, it's delete. I'm not going crazy. It is delete. Don't tell me I'm wrong, computer. Okay. Right. Okay, so then we're gonna do a public inline window get window const. So all we're doing, because that's private, is we're creating a public method of getting the window. We don't ever want to set it this way, so we only want to have a getter. We're going to return main window. Okay, there we go. Right, let's go over here. And all right, all of this can go now. And then we're gonna do Vulkan test dot get window, which I think then becomes, there we go. And then we'll do while not closed that way. Out. Whoa, what the shit did I do there? Right. Okay, let's build and see what happens, and then we'll run it. Hey! All right, for some reason we're still only getting 2 extensions when we do it this way, and I don't know why. I honestly do not know why we're only getting 2 extensions when we do it this way and 18 when we do it the other way. Also, hang on. Just wanted to test something really quickly. Okay. So I didn't put that in there. I was surprised that was actually working. And this came before the window closed bit here. Again, I just want to see what I'm not getting right here. Oh, no. Nope, that wouldn't be it. What? Okay, I'm going to assume that it's working correctly for now, because it appears to be. And we have a Vulkan renderer at least initializing. So yeah. Right. I have just spent 2 hours doing the Vulkan part. So what we're gonna do now is, now that we have the hey, welcome in, K-Beard. Now that we have Vulkan actually loaded, we're gonna return back to our shaders and back to our OpenGL shaders, because I don't know where to go from here. I actually planned only to get the Vulkan renderer up and running. It's up and running. We don't have anything we can see right now, and I don't know why I'm getting different extension accounts, not accounts, on the same thing that I'm doing. So, instead of banging my head against the wall trying to figure out what that is, I'm going to spend some time off stream doing some research. If anyone here knows Vulkan and knows why, if I'm doing the same thing but in 2 different locations, I'm getting a different number of my extensions, please let me know, because I legitimately do not know what just happened there. Right. I'm going to close out the Vulkan stuff, though, and we're going to return to the OpenGL shaders. So, I'm actually going to move the ones we're currently working with down here and leave the completed tests up here. Oh, whoops. So where we left off, I've already put this on stream a couple of times, I know, but I'm going to put it on again, is we have a single renderer for our shader. So each of these 3 boxes, each of these 3 sprites or 2D render targets are individually rendered. The only difference between them, besides their translation, is their color. So we have red at the bottom, purple here, and blue up here, right? The only difference between them, again, is color and location. And it is not performant to have them rendered individually. So instead of having them rendered individually, what I want to do is I want to create an instance renderer or a batch renderer. I've seen it called both. So like when you talk about, take your time, K-Beard. And again, if you want to talk about it off stream, if you know the Vulkan stuff, you want to talk about it off stream, let me know. Quadri, if you know how that part works as well, please let me know. If you don't, that's also fine. So instead of having these render individually, what we want to do is I want to group them or chunk them and pass them as a group through to our OpenGL renderer. And yeah, that's the second thing we're going to do. I am not going to be more confident in GLSL by the end of today like I planned on. In fact, I feel my brain kind of melting. So let me just get rid of that. And also, actually, I forgot to do a couple of checks really quickly. Let's pop open the logs here. So yeah, we're getting, everything is loading in nicely. Our logs are outputting things that are kind of useful. All right, if we're not working with our GL stuff, yeah. So hey, K-Beard, do you call it batching or instancing? Because I've seen both terms, and instancing bugs me but is what I'm used to from Unreal calling it instance static meshes or instance hierarchical static meshes. But to me, it's just a batch. You're creating a batch of things to render. So, like, I've seen both terms. I don't know what people are happy with. That's why I have it on my to-do thing. So if you follow the mouse, just... Wow, I can't see my mouse on the screen. Huh. What the heck? Oh, there's my... Okay, I see it. The mouse color is different on the stream for some reason. So yeah, if you look at over just to the... I wish my mouse is highlighted. I need to get a highlighter on there. Look under my picture. It's the second goal. I have it listed as both. Right. So I'm going to create a 2D renderer for this, I guess. Sorry, I'm moving OBS over because it's just annoying where it's located for me right now. So to do this, again, I'm just going to... I hate the fact this opens every time. I wish that would just stay closed. Let's go into my renderers, and we have our renderer 2D base here, right? So we're going to create a child of this called renderer 2D, and that's going to be our standard 2D renderer. So I'm just going to create new item. It's going to be a header file because we're in the header, and I'm going to name this renderer 2D. Yeah, I would personally, I would call it batching too, to be fair. Like, to me, it makes more sense than instance because you are batching the things, you're putting them through. And to me, an instance is the particular instance of an object. So I don't like calling it an instance. Like, to me, it makes me think something completely different than how Unreal uses it. And then in our source, we'll create a implementation or CPP file called renderer 2D. All right, you can pop over here, over to my C++ IDEO. And just very quickly include headers renderer 2D. Right. And we're going to need to include the parent here. So include, and that's going to be renderer 2D base. So that's our parent class. So we'll use the same namespace. Let's actually open up the parent class really quickly. There we go. In fact, actually, I'm going to copy all of this for a moment. Screw it. I'm copying all of it. Also, I forgot to put my copyright notices in the things today, but I'll do that later. Right. So this is actually going to be class renderer 2D. And we are inheriting from public renderer 2D base. Cool. Let's get rid of this stuff for a moment. Sorry, I'm just thinking, and my brain just did a "what are you doing today" thing in my own head. Right, we're gonna do our constructors and destructors like usual. Window, you have a constructor tag in there. Thank you. Right. The base doesn't have one because we don't actually ever use it. It's meant to be abstracted out. There we go. Okay. And our constructor, of course, will be renderer 2D. We will want a destructor. Of course, it would be helpful if I put a terminator in there. So there is our destructor. We do not need to override. Wait, do I even have... Sorry, my phone is blinking at me over there. Give me a second. Luca, if you're still here, thank you. I just saw the message you sent me. No, we don't have a virtual one here. Okay. Let me just very quickly go over here, and we're going to define these. Right. Boink. I'd rather use using namespace, but for some reason, every time I do, it freaks out at me. So we're just going to actually encapsulate it within the namespace like before instead of saying using namespace. All right. There we go. Yeah, I don't know what we're going to be deleting or not in there. So we now have declared these things. There's nothing in there yet. We need a way to store our vertex array object and our vertex buffer object. Give me 1 second. I want to take a look at our index buffer because at the end of the day, it's the index buffer we're going to use. I honestly, I'm not entirely sure. All right. So let's just grab that so that I can go ahead and drop this in here above methods. Sorry, I have, again, a very particular way I like to do things. It's constructors, attributes, methods. All right, where did my index buffer go again? Did I close it out by accident? I also want my vertex buffer, my vertex array. Screw it. I want to go to my simple renderer 2D, but I want the class file simple renderer 2D. Boink. Right. So we got the object. We bind to UAO, the vertex object array, then we do the index buffer. So if my brain ain't completely shot, which to be fair, it might be, then what we're gonna want to do is we want to store everything in the index buffer. At least I think. So we're going to need our index buffer. Cool. So that means that we need to include index buffer. And we're going to make a variable for that. So index buffer, which is going to need to be a pointer, of course, because we're going to instantiate it here. It doesn't exist already. Actually, that's not why it's of course, but I'm blanking on a good explanation. Also, really quickly, just to be on the pedantically safe side, we are going to put the constructor and destructor in the public scope and our member attributes in, I was supposed to say methods, by the way. Sorry, I keep thinking there's something on my face, which is why I'm like staring at myself in the camera, like, what is on my face? And I just realized it's on the camera, it's on the screen. Yeah, that was not the cleanest way to do that, I realized, but it's bugging me, and I want whatever that is. Oh, it's from when I sneezed earlier on the stream. Cool, that's disgusting. That's not really, I'm just making a joke. Did I sneeze on today's stream? I don't think I have. So we want an index buffer. We're going to store everything there. I am an idiot, by the way. We're overwriting this. I don't know why I got rid of this. All right. We're going to do it in the correct area. We want access to them. I think that's how we did it in our simple renderer 2D really quickly. I'm just going to double check. Yeah, we did. Okay. And then, of course, sorry, I will actually fix that in a minute. Overriding, again, you don't actually need to use the C++, I think it's 11 or 14 keyword override, but it is an optional but useful one to have. Oh, yeah, no, this is an easy name. Index buffer. Duh. Okay, so that's our index buffer. And where's my index buffer again? That's not what I wanted. Sorry. I want renderable 2D base. Cool. Okay, this is a class that I really want at the end of the day because it's storing everything else we need. Do we even need an index buffer then? Go away. Do we actually need an index buffer if that's already in here? Actually, I think we might need a vertex buffer based on what's missing. No, it's not a vertex buffer. Oh my god. Hang on. We have a V. Where the shit is the attributes? There we go. We have an index buffer. We have a vertex array. We don't have a vertex buffer. Who knows? Sorry, I'm just looking at something while I'm thinking about this. I'm just looking at my document here still. All right, I know I'm going to need an unsigned integer that is a number of things we're passing in. So we're going to use the GL one for that. So yeah, integer, and this will be our index count. Is that the right one? OpenGL types. I have no idea what the heck I'm gonna find this on. Yeah, we go. Yep, okay, that is what I'm looking for. Cause it's never gonna be 0. I'd just rather use size t, but we're using OpenGL, and I don't feel like trying to convert that over and dealing with whatever. I think it should automatically convert over, to be fair, but whatevs. Right. So that is the number of things we're gonna be the number of indices we're passing through. Which means I could just name it indices, to be fair, but I'm gonna name it index. I didn't count before, so we'll do count again here. All right, let's just do our submit and flush at least, because, yeah. That's going to be a bit easier to tackle right now while I'm trying to figure out how I'm going to actually do this. Sorry for hiccuping in your ears, everyone. I'm going to hiccup again in a few minutes, probably. I can feel it. At least it wasn't burping. Oh shit, I forgot to get rid of the override. Alright. So. Let's go here. We have a get position we do. Okay, I just want to make sure I did all that. So, I'm going to cheat, actually. And so I'm just taking a look at how I did this here. I didn't fail. I should get rid of that comment. We're not gonna have a queue. So when we submit, we're going to be doing this part of the flush. Yeah, because we're okay. So what we're trying to do is avoid having to develop this queue, this vector of things to be submitted. And we're trying to bypass that and just go in one lump sum, in one batch. So I have the lurking feeling that in order to achieve this, what we need to do is, instead of storing things in an array here, or in a vector here, really, we start pushing things already. We copy part of the flush over to that. Or sorry, yeah, part of the flush over to the submit. So, So, to do that, let's just go to render target And let's see if we can get all right, so we need 3 pieces. We need the size, the color, and the scale. Sorry, scale, color, translation. So we'll do translation, scale, color, because that's the order in which I think about them in. So we want to get the position. Now, where are we storing this? All right, we're going to create a new 3 vector for this. So let me just go down here for a minute. UMath vec3, and this will be position. And there we go. Okay, let's copy this line. And then I said scale is next. So is that actually what I named it? Is scale? Yeah. Get scale, and scale is a vec2. Yeah, these should be references then. We don't want to copy it. We want to pass the reference. Why are you not happy with me? What are you not happy about? Qualifier is dropped in binding of reference of type neuron engine UMath vec3 to initial or constant. Yeah. Right. Okay, I'm not sure why you're not happy with me. By returning a non-const reference to a member of your class, you're giving access. But it's const here. Const. Oh. There we go. That was stupid of me. Sorry about that. I just forgot to actually, make the const thing that we're storing const. So that would explain that bug. Okay. All right. So that was scale, and now we need color. So guess const UMath vec4. Scale. Color. And get color. Okay. There we go. So we're past that through. What do we do next? We're going to need to pass this to our buffer. So, oh, that's renderable 2D. I'm like, where's my buffer? Oh, there's a reference to the buffer I'm looking for. So let's pop over to our index buffer for a moment here. We need a place to store this. I feel like I want to store it here in my index buffer. But to be fair, I'm not entirely sure that's right. So, what we're looking at is the position, the scale, and color. Or translation scale. Translation, scale, and color. So, Sorry, I am just thinking, and I'm having a brain fart. We want to store this. This is what we want to store. We also want to store scale. Or sorry, not scale, it's in there. Position. Now, position we don't really need to store, actually, because we're just going to pass that through. So what we want to do is actually store these things. All right? So, and this is to create it. So we're not actually creating it yet. We're storing it. And then we want to pass that information on to the... Okay, so to do that... we're going to need a structure. Okay, the question then becomes, do we want this structure to be part of this class here, on screen now, or do we want it to be a separate thing on its own? And to answer that question, what we're going to do is we're going to take a 5-minute break, because I really need the bathroom now. And I also need to stretch my legs because my bad leg has gone numb. I'll be back in a moment. In the meantime, enjoy the music. That, my friends, was a mistake. I went outside to my backyard to stretch my legs, and oh my god, it's warm out, and I want to be outside. Don't worry, I'm actually going to finish this up. It also give me a minute to clear my head and think about it. My gut says to make it a... I'll deal with that later. My gut says to make it a separate thing, but when I thought about it outside, I realized if I do that, then I'm going to be including a crap ton of other things, and anything that derives from this class, this base class, because it's meant to be an abstract class at the end of the day, really. Well, I'm not using it really as an abstract class, but it should be in here because I'm going to be using this elsewhere. Or I'm going to be using it in derived children, that is. And I'm not going to be needing it as an independent thing where I can call it up for something else. So, to achieve what I'm trying to do, I'm going to store this information as a structure up here. And it's a vec3 and a vec4. That's all it is. It's an array of 3 and an array of 4. So we're going to store this as a vector. Sorry, as a structure is what I meant to say. So we're going to create a new struct. And we're going to name this struct our render data. And in render data, what we're going to have, as I said, is a umath vec3 and we're going to call it vertices. Actually, no, it's going to be one vertex. So it's going to be a singular one, which we store here, which we pass to vertices, and we'll keep the same structure. So it knows that the y in this vertex is that y, the x in this vertex is that x, etc., etc. And color, it's the same idea. So it's just going to be umath. It'll be a vec4 called color. And we're going to store the color data there. Right. And yeah, that's plural because we're talking about multiple colors there being passed through, even though it's every vertice is the color. So then what we're going to do here is store that data. So to do that, what we need to do then is to do that, what we need to do is then sorry, I'm just having a brain fart here for a moment. We need to create a variable for this. So okay, go back to our 2D renderer. And actually, let's go back here for a second so we can copy this name. It's render data. And this is going to be a pointer, of course. And what will we call this? Well, I'm going to call it render data for now, because I can't think of a better name for it. Right. So what we're going to do is we're going to do vertex. That's our scale, our position. Okay, fuck it. Hang on. Pardon my language. Let's do render data for the color first, because that's easy. It's just Okay, this one is position. Okay, right, there we go. So now that we've done that, we need to... It's a pointer. The reason why it's a pointer is we're using it as an array of these things. So we're actually using it more like a buffer at the end of the day. But we're going to... we can't just resize it, can we? Can we just resize it? Can we increment it? Huh, we can. Okay, so we're gonna up the size at this point because then we need space for the next one we're putting in. Once we have that next one put in, we recycle this over and over again, of course, where then we're gonna pass the data out and render the data. Right. We're drawing a square, which is 8 vertices. We want to remove 2 of them, so we're moving it to 6. We then want to store each of those per that 6, or 8, no, 6, because we're getting rid of 2. 0, 1, 2, 0, 1, 2. So, yeah, we're getting rid of those 2. That's 6 instead of... all right, so give me a second. I'm gonna go here because I need to look at this for a second. I think we're putting the position and size together. Yeah, that's I think the easiest way to do this is putting the position and size together. So that we're gonna have to do that a total of 3 times. Once here, and once here. So to achieve that, then what we are gonna do is we're gonna do render data. And we're going to go to the vertex again, and we're going to do umath. This is not saying fmath, because then I'm talking about Unreal. Umath, and it's going to be a vec3, because it's still 3 bits of data we're passing in. And the first one, we don't change the anything on it, so we have position x. We do nothing with that. Then we have position y. And now for position y, what we're going to do, because it's also scale, we're going to do scale y. And then we're going to do position z, which would be 0 there. So that's position z. So that's this line, line 40 done. And now line 42, what the fudge are you giving me an issue with there? Okay. Let's just copy this line that I'm currently on. Let's paste this down here. This is going to be x. Sorry, I'm looking for this window. Plus, is it position or scale? It's position. We're adding scale in. And then we're going to do scale x. And then y is y there. Okay. And then we need this one more time down here. And we're going to delete this one, because we aren't passing the scale on the y-axis through. We're only doing the scale on the z, or x. So scale x, there we go. Right, so that's that done. We need to do the same for color. And because we're drawing this by each of the vertices, you got to think about this by object, think about this by the vertices of the object. We're going to want to pass the color through as well. I mean, not because of that, but we're going to want to pass the color through as well. Because of what I just said a moment ago, what I want to do is I want to clump these based on the vertices. Okay. So, is that right? I think so. I really, really hope I'm right. So this should be this line here. Then we're doing this line. Oh, crap. That's that line. Then we're doing this line, then this line, then this line. I'm going to combine these in just to make my life easier, because that's what we did up here. We can put the color in already up there. So we're just going to do the same down here. All right. And these are zeros anyway, so that makes sense. Does that make sense for this one, actually? Whatevs. We're storing the data here. We're going to split it up here and here, which corresponds to that 0 anyway, I think. I have no idea if that's right, what I just said. We'll find out by the end of the stream, though. And what we're going to do then is nothing. We're going to do nothing. Because we aren't changing any of it. We're just literally passing it through. So we're just going to do color. Because nothing changes here. It's, yeah, okay. And again, this is just one object. Each of these just represents one object. So if we're batching it, then we're going to increment each of these. Okay. I think that's right. And so we're always drawing 6. So what we're going to do then is take our index count and make sure that we are actually adding in 6 of them to what we currently have, so that we always have that room for 6 vertices to be put in. Yeah, that's our submit. That is everything we need to do for submit, I think. I'm kind of guessing at it here. Right, let's go down to our flush then. And I'm going to cheat. I'm going to find in here. So we aren't using a vertex array, so we want to bind. What are we binding it to then? Here's my vertex array object. Thank you. Okay, so we're going to do this. Now, we need something for array ID. Just let me take a look at what that is defined as. And this is our vertex array. And that is a GL unsigned int. All right, so we need to create a reference for that. We just need the index number for it, because we're going to be passing, yeah, we just need the index number. So it's GL, was it unsigned int? I just literally looked at it, now I'm blinking. Yeah, it's a, you know what? Copy. All right, and instead of that, this will be our vertex object ID. And we will default it out to 0. It'll be changed, of course, down the road, but that's just to avoid any compilers or warnings of, you haven't initialized this variable. And then let's go back here. No, wrong one. Let's go back here, and we're going to take this line. Let's paste it in here. Instead of array ID, we have our virtual. you know what? That ID is going to really throw me off. We're going to just pass in our virtual vertex object or array object. Even though it's not really the object, but it's our reference to it at least. All right. I need the index buffer open. All right. What do we need to get from the index buffer? That's the wrong thing. However, you're going here for a minute. And index buffer, you're coming here. I put the index buffer there. Okay. So for our index buffer, wait, hang on, crap. Yeah, we have our index buffer. So then we need to bind our index buffer. So let's go back here, and then we're gonna do our index buffer, and then we want to bind buffer. And let's just go back to here for a second. And our bind buffer, we don't have anything to pass in. Okay, that makes life a little bit easier. We then want to draw this as part of the flush. So let's go back to our simple here, and let's grab our draw line and drop that in there. Now, it's not renderable. What was renderable in this one? This is simple renderer 2D, so let's grab simple renderer 2D header, and come on. And we defined renderable up there as the front of our render queue. Now we don't have a queue this time around, so we're going to pass in the index instead. Right. So when I say index, I mean our count. So, because that's what we're doing here. If you follow that through, all we're doing is getting our count, but we have our count here. So we're just going to grab that and replace this. And yeah, that looks right. We'll get an error if that's wrong. So I think that's right now, but we will get an error in our output log. Yeah, we set that up last time. We will get an error in our output log and potentially also in the console. I can't remember if I left that in or not, and I'm not going to look it up because it ain't a big deal. And then, of course, we need to unbind everything just like we did before. And then we want to clear our index count because, hey, we're done. So, well, that last one's the easiest for me to do right now. Okay, I can just think about that. All right, and again, we're going to think about this like a sandwich. That's the plate we're sitting on. Yes, I actually do visualize this like a sandwich. We have our top bun, our first condiment, our meat, which is the element drawing, our lower condiment, which will be our index buffer, which we then want to unbind. So index buffer. And then we want to unbind this buffer. Just going to double check we don't pass any arguments there. We don't. Okay. And I would have got an error there. I realized if I did pass anything through, but I like double checking because I'm a paranoid person like that. And, well, here's the top of our sandwich. And if we just pass in 0, well, then we're unbinding that VAO buffer. Cool. That's flush done. Right. Sorry, I am thinking now. All right, that's our flush and our submit. That makes sense to me. For our render constructor, we need to actually give it something to work with. So we need to create our vertex arrays. We need to bind those. We need to do the same for our buffers overall. So we're going to copy this line for a moment because we need 2 of these now. And we need our virtual our vertex buffer objects as well. Okay. So this is what we did last week, by the way, setting these up. So now we're going to bind these differently, and we're going to do that on the constructor. So in the constructor, what we're going to do is we're going to do GL gen buffers? No. Gen vertex array. So we're making the arrays. And we're going to store that in our VAO. And then we need to do, crap. Is it 1 or 0? I can never remember. Vertex array. Oh crap, I did it in my main. That's my test. GFW test. My number of attempts to try to figure out how to actually draw something using GLW. OpenGL, I mean, not GLW. I meant to say GLFW or OpenGL. It is 1. Cool. And that's useful because I got that wrong. That should be a reference to it. Thank you. And then we're going to do the same down here with our bind buffer. So I'm actually just going to copy this line. Why are you yelling at me? Why don't you like this? And again, we're going to pass that to the same one. And what the hell did I name you? Oh, it's not array index. That's why. It's VAO, isn't it? Yeah, it's VAO. And you are vertex buffer object, and also you are a reference. Cool. Why are you yelling at me? VAO is undefined. Sorry, I was completely in the wrong class. I wasn't paying attention to where I was at. Right, that's 1. There we go. And I'm going to go back here, copy that line again, and change that to 1. And it's a reference to our VBO. Okay. Right. Why did that work up there then? Oh, it's not binding them yet. That's why. I'm generating them. And it's going to be buffers still, isn't it? Yeah, it's buffers. Gen buffers. There we go. Okay. Then we want to bind them. Okay, and that's the thing I was copying over here. So we're going to take that and paste that down there. And this is VBO. Okay. What else do we need? We need to actually bind the vertex array as well. So, it's this line we want. And instead of array ID, it's our, well, technically it's still an ID, but I just couldn't think of a better name. So we're going to call it vertex array object. Then we do the buffer data. Okay, and what we're going to do is still GL array buffer. Now, still static draw. We aren't passing anything into it, so we can't do that math the same way we did before. So what we need is a... we need a thing that does a thing. All right, so we need the size of. So we need to say what our maximum number of sprites or 2D targets or render targets or whatever the heck you want to call them. How many of them can there be? So here we're going to set the limit of our buffer. And we're going to do that by declaring the size of said buffer. Okay, and that's going to be the size of vertices. Size of vertices previously has now been replaced with this. So we're getting rid of this thing, and we're doing the size of this render data times the number of actual vertices are we drawing, so that's going to be 4, multiplied by our buffer limit, the number of things we're going to draw. So I'm just going to write that down for myself, otherwise I'm going to forget. This is the size of render data times num of vertices, which is, by the way, 4, times num of sprites. Okay. So, am I going to need this data anywhere else is my next question. Because if I need it elsewhere, then it behooves me to declare and initialize these elsewhere or to create defines for them. If I'm not going to use it elsewhere, then I could just go ahead and create a really wonky second argument here. I am going to need some of this data elsewhere. I'm thinking about this. I'm going to need some of the data elsewhere to help determine what where my delimiters are. If you remember from last week, we're talking about determining where the end of this set of numbers we're putting in is it, you know, vec 2, vec 3, vec 4. We need it for that, probably being the operative word. I'm not entirely sure if that's accurate. I am probably going to need it for I'm going to need it for math elsewhere, because we've used the size of in other places. And if you remember, I really struggled with that last week, actually. So yeah, I'm going to do this in the header, I guess. So that's our renderer 2D. So how the heck do I want to do this then, if I want to define it elsewhere to be used? All right, const max render targets, and for now we're just gonna set this to 1,000 because yeah. Well, first let me fix that typo there, and second, okay, There we go. Next, what we're going to do then is, so that's we need the size of our render data. Okay, that's fairly simple. It'll be another const. I'm going to do size t for now. I'll call this vertex size. And this will be equal to the size of, and then, what did I call it in here? Something data? Render data. Okay. And then we need the number of vertices being drawn. No. Yes, we do need that. What we need, however, is not that. That only tells us per vertex. And is it 4 or 6 now we're thinking about? 1, 2, 3, 4. 4. So it is times 4. I was right. That's actually the size of the damn thing. So it's going to be const size t. And we'll call this render scale. And this will be our vertex size times by 4. I could make these literals, I guess. I doubt that I'll actually get that accurate because I might change that in the future. And then we need our max buffer size. So const. Actually, should this be sized? Give me a second. So what I'm doing is, yeah. Oh, it's GL size I. Okay, cool. We'll actually switch over to that then. Actually, hang on. Let me get that back over here, and it was open GL types is what I wanted. And this is GL size I pointer. So GL size I is what we're going to end up using for these instead. All right, and that's going to be our, what did I say, buffer limit, buffer size, buffer, we're going to call buffer size because I can't think of what I called it a second ago. And that's going to be our render scale times max render targets. Okay. So we can bring that into here instead. Oh, wait, no. Yeah, size of vertices. And well, right now we're not drawing it. So can we pass in null? I mean, it is a void. We aren't drawing anything yet. And I remember a few weeks ago panicking over the fact that this was a void. Yeah, we have nothing we're actually passing in. So that's going to be a null. Actually, should that be a null pointer or null? Give me a second. Let me get that file back on screen. It's a pointer. So I'm going to do null pointer instead. Okay. All right, so the next thing we need to do is have the information for the shaders itself. And our structures of our shader are 0 and 1, where 0 is our position and scale, and 1 is our color. So because those are going to be static, we're just going to go ahead and define them up here, and that will be define, and this will be vertex index. That's going to be 0. And then we'll do our color index, which is 1. So if we remember, if we pop open our shader, which I realize is the test folder right now, because again, we're going to be putting in other shaders and testing with it. We're going to have our Vulkan-based triangle ones. We're going to have our tessellation-based ones. We're going to have a whole bunch. But let's take a look at our basic right now. Yeah, it's 0 and 1. Okay, I was right. I thought I put it in 0 and 1 and not 1 and 2 for some reason. Okay. I'm actually going to move this over here. Sorry, I have it with what it's supposed to be. Okay. We need to pass that information over to our shaders and store it here so that we can actually render it. And how the shoot are we going to do that is a good question. We bind the vertex attribute. So we're going to need... I'm going to go to main. I think I know it's in here somewhere. Yeah, there we are. So we're doing this bit here, really. So I'm just going to copy this. Paste it here, and really quickly, I'm going to pop over to OpenGL really quickly and just search for this, just so I can get the argument list up. No, it's not a pointer. No, that's wrong. That's when we're trying to bind the shader itself when we don't have a rep, where we're trying to get the pointer of the shader. What do I want? I want GL. That's what I want to do next. This is the second step. What I need to get the attribute array, and I'm not sure how to do that. Oh, hang on. Let's try this on here. Oh, okay. Sorry. Non-array attributes values. So we want a vertex shader can read attributes that is not currently. That's a bit. So it's GL enable vertex attrib array. And what index? Okay. Thank you. And we're going to pass in. What did I just name them? Vertex index. Let's copy this down here. Why isn't that working? How much if I put in 0? Are you happy with that? Okay. Sorry, just give me a second. You know what? We'll do what we did down here. Const. Was it size I again? Oh, I still have that open from earlier. Did I accidentally close that window? Crap. I did. All right. It is, yeah, it's, so, yeah, okay. I just pasted that randomly into Discord. And what was it? Vertex index. And that's 0. Screw this. We're using the C++ constructor. Sorry, the modern C++ constructor. We're going to fix that up down here as well. All right. And then we need a color index, which is 1. All right, you guys can go bye-bye now. Cool. Wait, what? Are you working? No, you're not working now. Okay. Oh, no, redo everything. Okay. So this is the vertex index. There we go. And color index. There we go. All right. Sweet. Simple. Cool. Also, I just realized I've broken my own convention here. Yeah, I know. Eat me. Okay, let's fix this all up now. Okay, now we need to do the attribute pointer stuff, right? And I mean, we can just literally do what we did here. That's a bad example. All right, if you remember where I screwed up last week and I was trying to put a bug in to show you something and I really screwed it up, that's what we're doing here, but we're doing it in a reverse way. So it's using that same line. So we're going to take this, bring this down here. This is going to be 4 because we're now working at a vert 4. And the reason why we're doing that is, well, this is the color index. We could pass in 1, but hey, you know me from my Unreal tutorials, I like actually not using literals. Because if you change one of the literals, you have to change them all or you get weirdness. Whereas if we just change this value in our header, wherever the header is, right here, and then hey, all of them change and we don't get weird bugs. Right. Now, I don't think that this is right. Yeah, we don't know if we're passing in full. No, we do. Okay, hang on. Give me the arguments again. Oh, I really hate the fact that it doesn't pop up with the arguments. Didn't we just have this open like a moment ago? Did I really close the tab? So we have the index where we're passing it to. We have the size of it, the delimiter. We have the type. These are floats we're dealing with. Yep. We don't need to worry about normalizing just yet. Stride. Okay, so stride. Well, we need to worry about that this time around because we are looking inside of our, we're not using buffers to split things up. We have one giant buffer, and we need to tell it where to move the pointer in that buffer for this object. So, I think that is vertex size. No, it isn't. It's render scale. It's render scale, I think. No. It's one of these two. Let me think about this for a moment. This will be... No, it's gonna be size, not scale. So that's gonna be our stride. Right, and then what comes after our stride is our const pointer. Right. All right, so this one is definitely, the first one's definitely 0. I'm pretty sure of that, actually. The first one's 0. The second one, however, is it's off by 3 because we have the vertex, then the color, then the vertex, then the color. So what we're going to do for this one is, I think it's 3 times size of, and then we need the size of the particular thing we're passing in, which is a float. So it's GL float. And thanks for not putting the extra bracket in there. Why are you not liking this? Okay, so we're going to cast this to a const void, apparently. Const void. Why don't you like that? Oh, we need to pass this entire argument over to the void there. Okay. There we go. All right. Okay. Sorry if you can hear the wind again. We need to unbind. Oh wait, hang on. I skipped one. We have something to do before that even. I'm trying to remember where I did it actually, because I can't remember the keyword now. It's the sub indices I want to address next. And I don't remember. There it is. It's this bit here. We're going to copy these 2 lines just really quickly. All right. So this last one's really easy. It is, because we're doing with the arrays now, the elements. This is that one. For this one, it's gonna be the same thing, right? Okay, so let me just grab the thingamajigger for this. You know, I'm not actually sure with this one, so I'm not gonna try. And it seemed to make no difference last week when I removed it. So if I need it, then I'll add it back in. All right, now we need to create an offset that we can use. So to create our offset, is it 6 or 4? 6. Okay. So we need an offset by 6 units, or 6 values. 1, 2, 3, 4, 5, 6. Yeah, it's 6. Sorry, I had to actually count it out in my head in the table I have in my head. So 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. -1, 5. I really wish I kept that horrible paint thing I did last time. 0, 1, 2. Okay, 0, 0, 1, 2. 0, 1, 2 is over here. And on this side is 0, 1, 2, which becomes 3, 4, 5. All right, 3, 4, 5. So 3 gets removed, which puts 0 back in. Oh, it's the numbers I used last week. I'm an idiot. It's 0, 1, 2, 3, 2, 0. Except for, I think they have to be ordered correctly, and I think that was one of the bugs I had last week. So we're going to go to here. Nope. Is it in our renderable? Yeah, okay. These are the numbers. Yeah. All right. Pretty much we're doing what this is here, by the way. So to do that, what we need to do then is create an offset for that. And so we're going to use unsigned int 32t. We'll call this offset. We'll define it to 0. And then we're going to do a loop through our indices. So we'll do for size t I equals 0. I is less than something. Okay, we need to figure out what the size of our render queue is. Right? Right, I think. Question mark. Wait, that isn't right. Hang on. Oh, no, that is right. Okay, because I did that up there. I forgot I split that up. I split that out instead of combining it. All right, so how do we figure out the size of our thingamajiggers? I've gone over 4 hours. Shit. Each of the indices is 6, right? Right. Each of these is 6 and not 4. It's 4 we draw, but it's 6 in actuality. 1, 2, 3, 4, 5, 6. Yeah, it's 6. Okay, so it's gonna be const GL size I, and we'll call this index size, and that's gonna be 6 times. That's gonna double dip. Sorry, render scale double dip, buffer size makes no sense. It's max render targets. That's the only thing that makes sense. Okay, so we have our number of indices, or the size of our indices. All right, so that's the size of our indices. It's not the indices themselves. All right, so let's just do GL int equals. We want unsigned integer because we're using a size t down there. We can give this a name. We're gonna call this indices. Indices is going to be equal to size, right? I think this is right. So then if we do, why can't we just use size then? Why am I doing it this way? What the hell's wrong with me? So we'll just take index size here. And then we'll do I, and then it's the offset of 6. Okay, I think that's right. And then what we're gonna do is for each of these, we have 6 indices. And then we go on to the next one, and then the next one. That's why it's plus 6. Remember, because we have 6 indices in each set we're working with, or 6 indexes in each set we're working with. So we're gonna do. Ah, shit. That's why I was doing that. I needed a place to store it. All right. So it'll be indices. And then it's going to be the first one at itself. So we're going to, just to make my life easier, I'm going to do it this way. Because I know we're going to have to add to each one of these because we're doing 6 at a time. Each loop is 6 vertices. We are going to have to clean this up to make it neater and more performant. But right now, my brain not doing math. So you're going to then take the offset and add 0 to it. Why don't you like I here? Expression must be a pointer to object type, but it has an unsigned log. Okay. Oh, okay, that rid of the error, but that gives me an error here. Cool. No, that makes no sense to do. Why would we do this as a reference? New. And, actually, wait, hang on. I just wonder if I have the type wrong really quickly. Let me just change that type over there. Nope. Okay. So, let's make this into a pointer. Like I did a second ago. What did I do a second? Was that a pointer? Yeah. Let's try this. New. Okay. All right, that solved it. Before I forget to do this, then we're going to, on our, on our destructor here, sorry, I couldn't find it for a second. We are going to delete indices. Why can't we delete indices when you're doing this? Oh, okay. At the end of this, we'll delete indices because it's a local variable. Cool. Right. So we have 6 of these. How many do I have now? 2, 3, 4, 5, 6. Okay. All right. So this will be 1, 2, 3, 4, 5. Okay, and what are the numbers? 0, 1, 2, 2, 3, 0. Okay. Oh, yeah, fair enough. Did I put that in the wrong spot? Okay. And then we need to adjust the offset with this. And it's 4 because we double up on 2 of them, remember. So plus equals 4. Right. And then we need to create the buffer that we're storing this stuff into. We have to do that before the indices. And we already have the buffer. It's the, you can't see where I'm pointing, I should move the mouse. It's our index buffer. So we're going to take our index. Oh, is that right? Is that index buffer I want? Yes, our index buffer I want. We're going to take our index buffer. Sorry, I'm trying to look over the mouse. That doesn't seem right. What did I just do wrong before I do this? Okay. So index buffer, and we get a pointer, so it's a new. Are creating a new index buffer, and we need to pass into the argument something. Our account and our data. So our data and our count we've just done up there, and that is our indices for our stuff. So indices, is that right? Do I have this in the right order? G will ent 64. Yeah, that's indices. Okay, and our data type. Wait, now is that right? Okay, and our data type is, I think, the render. No, not the scale. The index size. No. Crap. I know, it's our index size. I might have this backwards, by the way. I'll find out the fun way a little bit later on. Okay, go back to our index buffer here. I think I had these backwards. Okay. There we go. I'm just going to build to see if there are any errors. And I've just realized it's now gone 4:30. Unfortunately, I will actually have to call it here because I have things I need to take care of out in the real world. That, and I'm getting a bit stir crazy staring at the screen. Now, what I'm going to be doing between these two live streams is I'm going to be updating this to clean this up because I'm sure there has to be a more performant way to do this, more performant way to get that information as well. At least I hope there is. I'm going to put a space there so I know what these are two different chunks of things. I will continue probably working on the Vulkan renderer and the OpenGL renderers individually on Discord. For those of you who are unaware, I do live stream on Discord fairly regularly. When I live stream on Discord, what I'm doing is I'm tending to I'm tending to work on this stuff or other things that you see. So if you want to see some stuff between the YouTube live streams, make sure to join Discord. The link is down in the description below. In addition, this video and this series have been brought to you by Patreon sponsors like Luca, who was in earlier. And you too can help the channel out. And all you have to... Sorry, I have a tendency to look at this screen when I'm working, even though the camera is here. So sorry about that. And you too can support this channel. And all you have to do is hit that like button below. I cannot stress how much that helps this channel. And remember, new videos for tutorial series come out on Monday, and live streams are on Monday between 5 and 9 British time. So British summertime during the summer and GMT during the winter. And live streams are every Friday at 5 p.m. And Saturday at 12:30 p.m. And again, that is British summertime during the summer and GMT during the winter. But if you want to make sure you're here when these videos and these live streams go out, make sure then to hit the subscribe button. And if you want to make sure you actually are here for them, hit the notify or select all notifications, and the notify bell will do that for you. And if you want to take your support a bit further and you want access to project files for all the tutorials that I am doing, please note the stress of the word tutorial there, and you want early access to the videos, then consider becoming a Patreon sponsor. Patreon sponsors get early access to all tutorials and access to project files once they're completed at the middle tiers, and at the upper tiers, access to project files as they're ongoing or completed. And as always, it's been wonderful seeing you all. I look forward to seeing you in the next video, which comes out again on Monday between 5 p.m. and 9 p.m. typically, BST and GMT if you're going for the non-summertime. And I look forward to seeing you in one of those videos. And I hope that you have a wonderful day. I really messed that up. Let me try that again. Wonderful day. Full day.